video lecture on Introduction to C Programming for ENEE150 under Professor Yang. So first, I'd like to start off with an outline. Briefly, what we're going to cover today is an overview of C, and inside we're going to talk about the history of C programming and why C is important to us, and some of the drawbacks and potential failures of C. And then we'll go and talk more about the general form of programming languages, the syntax, and how to structure programs and things like that, in addition to some unique C language features. So first, let's talk about history and philosophy of C. C was essentially developed in 1972 by Dennis Ritchie at AT&T Bell Labs for the use of Linux. C is a very, very common language in today's world in the sense that it's the most commonly used languages that is basically used for system software. Today, C programming is very machine independent, which means that it can be compiled and ran on a wide variety of platforms and operating systems, such as Mac OS X, Linux obviously, and Windows through PuTTY or other SSH devices as well. So why C? Many companies research and currently work in C, and basically C is a great language to basically use. And why is it? It's because the main optimization that C provides us is the ability to provide fast program execution speed. So yes, C looks great on your resume and allows you to write clean and compact code, but the main feature that it brings us is the fact that it executes much faster than many other languages such as Java that runs on a Java virtual machine, and Python, and etc. C has many great features that we can use, including low-level access to computer memory through pointers and memory addresses, machine addresses. And so basically with these pointers, we can basically reference certain memory locations and do whatever we want. C says, hey, you're the boss, you can go ahead and do whatever you want with this location. Store whatever information you need or whatever information you want. C can be compiled again on a variety of machines, just like we talked about before. So what are some drawbacks? What's missing here that we're missing? Well, so C is very interesting because C has very bad error detection. So the problem here is in C, you're the expert and you control everything. But when you write code in C and you send it to the compiler to interpret, the compiler doesn't always understand what you send it. And so it will show a general error. So it will say maybe error on line 5 or error on line 10. When in reality, the error you have isn't even on those lines. Maybe perhaps say it's on line 2. It's just that the compiler doesn't always know exactly what that general error stems from. And some other things that we should be concerned about is garbage collection, boundary checking, and exception handling. So garbage collection in C is done through a manual process. So basically there's no automatic Java garbage collection like Java provides through JVM, but the garbage collection rather is done through programmers individually through malloc and free. And basically there's no boundary checking for arrays, and what's interesting to note here is that if you have an array, you don't really know when it ends. You don't have the length or size of the array, and so you would have to pass that in as a parameter to a function if you were to use that array. For allocating memory segments, we deal with the same issue. And then we talk about more so on the exception handling side. C has no great way of basically handling exceptions. So what is exceptions? Exceptions basically like a runtime error. Basically, when you come across an undefined operation that you want to perform on a certain variable object. So the most common example in C is dividing by 0. So when there's a mathematical operation that you try to perform and for whatever reason you come across dividing by 0, well then that doesn't really work in C. And in addition, C has no native support for multi-threading or networking, which these facilities though can be achieved through other popular libraries. So we might ask ourselves, what is multi-threading? Basically, multi-threading is running more than one program on your processor at one time. So for example, you have Firefox and Google Chrome running on your desktop, and you basically want to do something on Firefox and then all of a sudden switch over to Chrome and just do something else. So all of that can work through multi-threading. So there's no inherent support for multi-threading on C. Yeah. So this right here is a very simple C program that we want to explain and walk you through. At the very top, you see something. You see the slash star, and then hello world.c star slash, and basically this represents a comment in C. So there are two ways to comment. You can either do slash slash, and that's a line comment, or a block of code comments. And block code comments basically are indicated by slash star and star slash. Basically, the comments inside of the block is something that the the compiler basically knows is not actually compiled into machine code. It's basically a special command that tells the compiler that what's in that block is something for us to interpret and not actually for the compiler to compile into source code. So whatever you want to put, usually for our class, student name, UID data, and the description of the project, typically it's not actually for the machine, but rather for the user to gain more information. So here we have a program called hello world.c, and hello world.c is basically a convention for all programmers to start with. I don't really know why, but let's start with it too. And so below we have the second line, we have pound include stdio.h. Pound include is a preprocessor directive. So whenever you see the word pound, everything under it is a preprocessor directive. And what that basically means is this is a library with some functionality that you might want to use later on. So what actually C does in this scenario, it goes and gets the machine code of stdio.h and basically pastes it into my machine code when I compile it. And all the functionalities that we can now use is included in my program. So yeah, so essentially that's what it means. So as we go down, we see that main is a function name. So you see int main taking in the parameter of void. So essentially what we have here is main has a return type of an int, and basically that means that when upon end of execution of the main function, it will return an integer, and this integer basically will represent some sort of data that you want to return back to the user. Every C program, we should note here, has a main. So why does it have a main? Because basically the compiler generates an exe file when you run it on the machine, and it will look for the main, and so everything inside of the main will basically be executed upon runtime. So basically, why is this important for us? Because if you don't have a main function, the machine really won't know what to execute. So in this case, moving on, main has a return type of an int, which we covered. Let's look at its parameters. Parameter right here of main is void, which means basically nothing or none. It doesn't really have a parameter, it doesn't take in anything, but future functionalities of a program might take in like an int, a char, a double as its potential parameters. So then we look at the library, pound include stdio.h. This provides us with two special functionalities, scanf and printf, as the two most common methods that we use in the stdio library. So as you can see here, we use the printf right here to print to the screen hello world. And this hello world basically on the user side will just display to the screen through standard output, hello world. It's very plain, it's very simple. We can do much more complicated and nice things with it in the future, but for right now, that's all we want. So it will just print hello world to the screen. So every instruction you might notice here is terminated with a semicolon. So this is how the compiler knows that it is the end of an instruction. And at the end of the main method, we return 0. So this is by convention to tell the program that, hey, we executed everything correctly, we are where we are supposed to be, and we like it. So we return 0.